Hello folks, today we're going to look at how to set up Hardhat and the best practices for doing that. If you're not familiar with Hardhat, it's basically an Ethereum development environment. It's a framework, a set of tools to make smart contract development with Solidity easier and more streamlined for you. So it comes with certain things built in, like right out of the box, and then certain other best practices that I think you should use and involve, whether you're setting up a new Hardhat project or you're looking to configure an existing project or adding it to an existing project. So the only really requirement for you to set this up is you must have installed Node.js on your computer. So I would recommend for new users to install the LTS version 16 point whatever or whatever LTS version it is when you're watching this video instead of the current version, because the LTS, the long-term support version, tends to be more stable and has fewer bugs and is more battle tested than sort of the whatever the current version is at the time. So make sure to install Node.js. And once you've done that, we're just going to open up your terminal and create a folder for this project. So I'm going to name it Hardhat tutorial. You can name it whatever you want. If you're on Windows, the steps are slightly different, but you can Google them or ask me down in the comments. Once you've created this folder, we need to install Hardhat as a dependency over here. So to do that, just run npm install save dev Hardhat, and this will install the Hardhat package, the Hardhat dependency, as an npm package. You can also use yarn or something else if you prefer, but we're just going to use npm here. So once that's installed, go ahead and type npx Hardhat, and this will sort of pop open the CLI to sort of like set up the project and sort of get you some sample code right out of the box. So we're going to choose create a JavaScript project. You can choose TypeScript if you want, but we're just going to go with JavaScript. Press enter, and then press enter for all the other questions as well. Install the project dependencies, and this may take up to a couple minutes, so we'll be back once it's done. All right, so the dependencies are now installed. Once we've done this, all right, so I'm just going to open this up in VS Code to take a look at the sample project it set up for us and what it starts us off with. So once it's open, you'll notice it has a little bit of a folder structure over here. Created some contracts, some scripts, a test folder, and a few different files. So if you look at lock.sol, it starts us off with this like basic smart contract. However, we're going to use our own. We're going to use something even more simple for the purposes of this tutorial. So I'm just going to create a file, hello world.sol, new sort of basic Solidity smart contract we're going to write. And in here, it's going to be super simple. Just going to do pragma solidity 0.8.9, and we're just going to say contract hello world, and it doesn't really do anything. It just has a string, hello equals hello, and then a function hello world that just like, it's a public function and it returns a string. Right, and it just returns hello. So this is going to be fairly a really simple contract for us to get going with, and we can get rid of lock.sol for now. So we're just going to use hello world.sol, and then if you look in the scripts folder, it comes with this deploy script that that was designed to sort of deploy the lock smart contract. We're going to replace this with something fairly simple for the hello world contract, because this varies from person to person, and I'm going to just keep this as simple as possible. So we're just going to change this to grab an instance of the hello world contract and then deploy to like hello world dot deploy. We don't have any constructor arguments or anything, so get rid of that for now. Now we're just going to wait for the contract to be deployed, and we're just going to say contract deployed to contract.address. All right, now this should look a lot more readable and a lot more straightforward. So now let's look at hardhat.config.js. So this is like the main configuration file for Hardhat. Anything you do that has to do with like changing Hardhat settings or anything all happens here. Now there's a few things to be mindful of. If you look in the deployment script, all it really does is fetch the contract, so fetch the hello world.sol contract through like get contract factory, and then calls the deploy function on it. And the contract itself is just like whatever, it can be any contract, right? How does it know which network to deploy it on, right? You might want to deploy on the Ethereum mainnet, you might want to deploy on a testnet, you might want to deploy on like Polygon or something like that. So currently, there's nothing telling Hardhat which network to deploy it to, and by default, it just kind of deploys on like a local testing environment that's not a real Ethereum network. So we're gonna fix that. And to fix that, we need to add a networks object here in the configuration and then give it a name. I'm going to use Gurley. We'll use the Ethereum Gurley test network for this. You can name it whatever you want, doesn't really matter. And then it's going to need a couple of things from us. It's going to need a URL and an account. Now what this is the URL is an Ethereum node. It needs access to an Ethereum node where when it's deploying the contract, it can go, hey, here's the code for my contract. I want to deploy this to the network. And then that Ethereum node takes it and broadcasts it to the rest of the network. So the transaction gets mined, and added to the blockchain, and your smart contract is then live. So to do that, we need access to an Ethereum node. So I would suggest going to Quick Node, which is this sort of free, it has a free tier, it's a free sort of Ethereum node service. There's a link in the description down below. But you go to Quick Node, what you want to do is create an endpoint. And for this case, again, I'm using the Ethereum Gurley test network. You might want to use something else like the Gnosis chain, Polygon, Binance, Optimism, Arbitrum, etc. But we're going to use Ethereum Gurley testnet, and just click continue and click create endpoint. So once the endpoint is created, it should give you an HTTP link, something like this. Now, keep that handy. We're going to come back to it. Now, the second thing you need is the account. So when you're deploying a contract on a real network, there's a couple of things to keep in mind. First of all, it's an address, right? Some user address is deploying that contract to the network. So it's making a transaction from that address. So for that reasons, for Hardhat to like deploy it from a given address, it needs access to the private key for that address, right? So you need to add a private key here that it can use to deploy the smart contract on the network. The second thing to be mindful of is that address must have some funds, must have some ETH or like Gurley ETH or testnet ETH, whatever. It must have some ETH so it can pay for the transaction. It can pay the gas fees for the transaction to deploy the contract. So to do that, what I've done is I've created a new wallet on myetherwallet.com. Ideally, if you're looking for a sort of a more longer term solution, I'd suggest just creating a new account through MetaMask, and then on MetaMask sort of using like a development account. Just make sure not to ever put any mainnet funds in it, any real funds in it, just in case it ever gets leaked. So keep an account specific for development with only testnet money on it. But for this tutorial, I'm just going to use my Ether wallet. So I've created a new account here, and I already have some Gurley ETH, but you probably don't. If you're creating a new account, you probably don't have any Gurley ETH. So if you don't have any Gurley ETH, copy your address and go to like a testnet faucet, something like the Chainlink faucet. Again, all the links are in the description. The Chainlink faucet tends to work well for Gurley, but basically go over here, input your wallet address, select like request 0.1 test ETH, log in via Twitter, do the verification, and then click on send request. And within like 10-15 seconds, you should have some Gurley ETH in your wallet like I do. So once you have that, we're going to need the private key of this account to deploy it from. On MetaMask, you can like export private key by going into the account settings. You can go over here and then account details and then click on export private key. On my Ether wallet, the way to do it is sort of clicking on your account into view paper wallet, and here's the private key. So now you can either add those two things directly in here or do something else. So the problem with adding those two things directly here is if and when you sort of push this code onto GitHub or something like that, you're leaking your private key and you're leaking your endpoint URL from QuickNode, which isn't good because other people can see it and they can like steal your funds from your account or like use your endpoint for their own things, making you hit the free tier limit, maybe increasing your bill on QuickNode and things like that. So we want to keep those things hidden. So we're going to make use of environment variables. So go back to your terminal and type in npm install --save dev .env. So .env is this npm package that lets us sort of use environment variables and read it from a .env file locally. So once this is installed in your hardhat.config.js file, add a line at the top saying require .env.config. Right, and this will read a .env file, and we will define that in a minute. And then we'll just sort of set the URL. Instead of hard coding it over here, we'll just do process.env.rpc_URL. And similarly in the accounts array, we'll just do process.env.privatekey. All right. And for the actually setting these values, create a new file in the root project, and like the root of the project over here, create a new .env file, and this is where we will actually define the values for those variables. So RPC URL and private key, and over here I'll just copy over this private key. You shouldn't never share your private key with other people, by the way. This is a fake wallet, so I'm putting this in a video. It doesn't have any actual money on it, but keep your private keys safe. So copy over the private key and copy over the RPC URL from QuickNode, and now when you will run this, .env will read those files from this .env file, and then you'll have access to these variables over here. Cool. So far so good. The next thing you typically want to do is you want to have a contract that is verified on Etherscan. So people can look at the source code for the contract, people can sort of interact with the contract on Etherscan. It's just a good thing to build trust and sort of let people know that your contract is not malicious and so on. Thankfully, Hardhat has that feature built in. So all you really need to do is in your deployment script, I suggest adding these things over here to automatically verify your contract on Etherscan. Let's add a line, await hre.run, and then the name of the command is verify:verify, and this takes two arguments, an address, this is the contract address, and some constructor arguments, which is passed as an array. So for the contract address, we have that through this variable over here. So you give it the contract address, and our simple hello world contract doesn't have a constructor, doesn't take any constructor arguments. If it did, you could have passed them through this array, but right now we're just going to leave it empty since we don't have any. And one more thing over here to be careful of is Etherscan is a third-party service, right? And it's not always up to date. Sometimes it can be slow. It can lag a few blocks behind the actual Ethereum blockchain. And for that reason, when your contract gets deployed, it may take a little while for Etherscan to realize that a contract has been deployed. So if you try to run the verification before Etherscan knows the contract has been deployed, it will just give you an error saying that there is nothing deployed at that address. So for that reason, typically you would also want to add a delay here, a little bit of a delay after the contract has deployed and before you do the verification. So you can wait for Etherscan to kind of catch up with the blockchain and catch up with the network. So to do that, I'm going to define a very simple sleep function. So the sleep function will take in an argument in milliseconds, so a certain amount of time to sleep for, and it will return a new promise, which will just kind of resolve once that time has passed. So it returns a new promise, and we're going to set a timeout in here, the timeout will complete after the amount of milliseconds have passed, and once the timeout is complete, it will just resolve the promise we're returning. And with the sleep function, we're just now going to add a delay for 15 seconds. You might have to play with this number a little bit. If this is giving you errors saying nothing has been deployed at that address, you're going to need to increase the sleep timer a little bit. If it seems it's too high, you can decrease it a little bit and so on. But yeah, feel free to play with this number. I'm going to start off with 15 seconds and hope it works. But yeah, now finally, to make this work, Etherscan is also a third-party service, so you also need an API key for Etherscan. And the way to do it is in your configuration file. We need to add an Etherscan object and then an API key over here. So this API key, again, you can get it by going to etherscan.io, signing into an account, and scrolling down to the API keys section. You're going to have to do this, create an account and get an API key. You might have to add and create a new API key. The Etherscan API key will work on the mainnet Ethereum blockchain and all testnets. For other chains like Polygon and Optimism and Arbitrum and such, you need to create accounts and request API keys separately for that from their respective block explorers. But for now, since we're using the Girly testnet, I'm just going to copy this API key right here. And again, we don't want to leak it from the config file. We're going to use an environment variable called etherscan_key. And in the .env file, I will just add that environment variable, etherscan_key equals to that. Great. And by the way, the reason the env file protects you is because if you look in this git ignore file that Hardhat creates for us, you'll see that .env is a file that is automatically ignored. So when you push to GitHub, when you push this project to GitHub, this file will not be added to GitHub. It will be ignored by Git. And for that reason, you're not leaking anything through your configuration, but when you're running it on your computer, you still have access to the values of these variables. So always highly suggest using .env and not hard coding values in here. Cool. Now that this is all done, let's test it and make sure everything is working as expected. So we're just going to run the deployment script. And the way to do that is npx hardhat run, and then the path of the script. So in this case, script/deploy.js, and then specify a network to run it against. This is the name of the network. So this can change depending on how you defined it, Girly or anything else. In my case, it's Girly. I'm going to press enter, and then we wait for the script to run. Also, it will take a little while because don't need to worry about this warning. It's just because it's a super simple contract, can be done a little better. It's kind of a useless contract, but you fix it according to your needs. So it's going to take a little while. So it's going to deploy the contract, and then it's going to sleep for 15 seconds. So it's going to take a little while for the whole thing to be done. But as you can see, we got here, contract has been deployed to this address, and now it's currently sleeping for the 15 seconds. And we can look up, oh, see, this is the error you get. So 15 seconds was not enough for it. It says that the failed to send contract verification because the Etherscan API responded that this address does not have bytecode, which means Etherscan still thinks that the contract hasn't really been deployed yet. So in this case, you would need to increase the sleep timer on it a little bit. So I'm just gonna set it to 45 seconds to be safe, and I'm going to run the command again, and I will come back once this command has finished running. I'm back, and as you can see, we deployed a new contract, and it said successfully submitted the source code for the contract for verification, and then successfully verified the contract on Etherscan. So if we open this link now for the contract, you'll see on Girly Etherscan that Etherscan now displays the source code for this. So we've been able to set up Hardhat for new deployment, configure Etherscan verification in it, define the network we want. By the way, if you need to change the network, if you're using something other than Girly, it doesn't matter what the name here is. The main thing you need to change is the RPC URL. So on QuickNode, instead of creating an RPC for Ethereum Girly like I did, you can create an RPC for something else, like the Optimism network or the Arbitrum network or something, and then use that URL here. Just make sure that your address has funds for it, ETH, on that chain to deploy to that network, and then it will just work. And you can change the name to this to be whatever you want. You can name it Optimism, Arbitrum, Testnet, Mainnet, whatever you want. And yeah, that has been setting up Hardhat with some best practices and creating a new JavaScript project. Thank you, and I'll see you in the next one.